Hello and welcome. In this video, we're going to take a look at the solutions to the Unit 5 review. Please remember to pause or rewind the video as necessary so you can learn this at your pace. Let's begin. In number 1, it says which of the following has a value of the square root of 36 plus 2 times the square root of 25. Evaluate this in pieces. Square root of 36 is 6, plus 2 times the square root of 25 is 5. We begin by taking a look at that, and this would be 6 plus 10, which is 16. Please make sure to show your work on the unit review. Number 2, 3 square root of 20 is equivalent to what? Well, 3 square root of 20 can be broken down into 3 square root of 4 square root of 5, because 4 is the largest perfect square root that divides into 20 with no remainder. Well, this would be the same as 3 square root of 4 times the square root of 5. If you break it up, take the square root of 4, and we get 3 times 2 times the square root of 5. Last step, multiply those two together as they are outside the square root and can be multiplied, and 3 times 2 would be 6 square root of 5. Number 3, which of the following is an irrational number? Well, rational numbers terminate or repeat. Irrational numbers never end, they never terminate, and they never repeat. So 5 terminates. That's a rational number. We're looking for irrational. 4/9, the square root of 4/9 would be 2/3, which as a decimal would be 0.66 repeating decimal. That is a rational number. Rational numbers repeat, remember, irrational numbers do not. The square root of 10, part C. If we put the square root of 10 in our calculator, we get about 3.16227766. Well, that's never ending, never repeating. There's our irrational number right there. Lastly, if you divide 8 and 3, you get about 2.66 as a repeating decimal. That is a rational number. Number 4, which of the following is a solution set to the quantity x plus 2 squared equals 25? Let's begin by taking the square root of both sides. And this becomes x plus 2 equals plus or minus 5. At this point, go ahead and write this as two equations. X plus 2 equals 5, that's the positive root. Or x plus 2 equals negative 5, that's the negative root. Solve each one. X is equal to 3 for one solution, and x is equal to negative 7 for the other solution. Again, please remember to show all work necessary. Number 5, the solution set to the quantity 4 x minus 4 squared equals 20. Go ahead and start by taking the square root of both sides. And we get x minus 4 is equal to plus or minus times the square root of 20. Well, that's the same as x minus 4 equals plus or minus times the square root of 4 times 5, because 4 is the largest perfect square that goes into 20. We can split that up. X minus 4 equals plus or minus square root of 4 times square root of 5, which in this case you need to take the square root of 4. So x minus 4 is equal to plus or minus 2 radical 5. Your last step would be to add 4 to both sides, and that gets x by itself. So x equals 4 plus or minus 2 radical 5. Number 6, which of the following equations has the same solution as x squared minus 10x plus 3? This, ladies and gentlemen, is in standard form. These are all in vertex form. To go from standard form to vertex form, you need to complete the square. Let's do that. X squared minus 10x plus, leave some space, leave a little more space, plus 3 equals 0. What goes in this empty space right here that you add? It's going to be b over 2 squared. B is negative 10, so let's go half of negative 10 would be negative 5. Square that, we get 25. But we subtract that same amount so that we're really just adding 0. And if I section this off, I get the quantity of x minus square root of 25 is 5, quantity squared. Negative 25 plus 3 would be minus 22 equals 0. Or number 3. Number 7, which of the following, when solving the equation x squared minus 20x plus 11 equals 0, using the method of completing the square, which of the following quantities must be added to form a perfect square trinomial? Well, to add and make a perfect square trinomial, you are adding, we add b over 2 squared. That's what we do. So let's figure out what b over 2 squared is. In this case, b is negative 20. So negative 20 over 2 squared would be negative 10 squared, which would be 100. So we'd be adding 100 to both sides in order to make a perfect square trinomial. Number 8, which of the following represents a solution to x squared plus 6x plus 4? Well, normally I would try to factor this right off the bat. When you factor something, you're looking for the factors of the last term, which are 4, 4 and 1, or 2 and 2. Neither of those will add up to 6, so that's not factorable. So I'm going to do this by completing the square. Since the leading coefficient is 1, that's a fairly fast way to do it. So x squared plus 6x plus, leave some space, plus 4 equals 0. You're leaving space for b over 2 squared. b is 6, 6 over 2 is 3, 3 squared is 9. Again, we subtract 9 over here, section that off, and this becomes x plus square root of 9 is 3, quantity squared, minus 5 equals 0. We're going to add 5 to both sides to begin solving this equation. And we get x plus 3 quantity squared equals 5. Well, go ahead and square root both sides of this thing. And we get x plus 3 is equal to this plus or minus the square root of 5. Finish this off by subtracting 3 both sides. And we get x is equal to negative 3, right here, plus or minus, two answers, the square root of 5. So negative 3 plus the square root of 5, that's one irrational solution, and negative 3 minus the square root of 5 would be the other irrational solution. Number 9, the positive solution to the quadratic equation 10x squared plus 11x minus 6 equals 0. Well, the leading coefficient is not 1, so I'm going to use the quadratic formula to do this one. Quadratic formula again is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2 times a. A is 10, b is 11, c is negative 6. So x is equal to negative 11, that's negative b, plus or minus the square root of b squared, that would be 11 squared, minus 4 times a times c. So a is 10, b is negative 6. All of that is over 2 times a, which is 2 times 10. Let's clean this up a bit. This would be negative 11 plus or minus the square root of, well, 11 squared is 121, minus a minus is a plus. Well, 4 times 10 is 40, plus 6 would be 240. So this multiplies to 240, and all of that is divided by 2 times 10, or 20. X is equal to negative 11 plus the square root of 361 over 20. Now, you should try and enter this in your calculator. It turns out that the square root of 361 is actually a rational number, a whole number, in fact. So this is negative 11 plus or minus 19. The square root of 361 is actually 19 over 20. So we have two answers, negative 11 plus 19 over 20, which would be 8 over 20, which would be 2 over 5. It's looking for positive solutions, so there's our answer right there. The other solution, the minus, that would be the negative solution, but we're not looking for that in this problem. Number 10, give an example of a non-integer. Well, integers, remember, are whole numbers or 0. Whole numbers, negative whole numbers, or 0. Those are integers. A non-integer would be anything in between whole numbers. So that would be your decimals or your fractions. But if we want a non-integer rational example, well, ladies and gentlemen, this is an open-ended problem. This means there's literally an infinite number of answers you could give. So I'm looking to give an answer that's a rational non-integer. So in other words, any number, any fraction or decimal that would be repeating or terminating. So for instance, 1/2, right, which is equal to 0.5. That terminates, that ends. That is a rational number. Irrational number. Well, that would be, there's a lot of examples. I mean, you could use pi, right? Pi is not just 3.14, it's 3.1415, blah, 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 and it just keeps going on and on and on. Pi would be an example. Another example of an irrational number would be any square root of a non-perfect square root. So square root of 2, square root of 3, square root of 5, square root of 7, square root of 6 even. Okay, any example of a non-perfect square root. Perfect square roots, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on. The square root of perfect squares gives you a whole number integer. A rational number, of course, would be a non-repeating, non-ending number. So the square root of any non-perfect square would be a good example of that. So these are a couple examples that you have for irrational numbers. Now, if you add your two numbers, if I add a rational number plus an irrational number, I always, always, always get an irrational number. The answer will be irrational. Number 11. Find all the values of x. So to solve for x, we need to get rid of 2, 5 squared, and 13. How about we start this by taking a look at getting rid of 13 to both sides and rewrite. 2 times the quantity x minus 5 squared equals 31 minus 13, which is 18. We'll go ahead and divide the two both sides. And we get x minus 5 quantity squared equals 9. Square root of both sides, plus or minus. And we get x minus 5 is equal to plus or minus 3. Last step, let's split this up into separate equations. X minus 5 equals the positive root, 3, or x minus 5 equals the negative root, negative 3. Solve each one. We'll do that by adding 5 to both sides of each equation to get x by itself. And x equals 8 for one solution, and x equals negative 3 plus 5, or 2, for the other solution. Number 12. Okay, again, find all values of x. So to do this, we have to get rid of the 2, the 5, the squared, and the 7. Let's begin by subtracting 7 from both sides and rewriting this. So we get the quantity of x plus 2 squared over 5 equals 16 minus 7, or 9. We can get rid of the fraction by multiplying both sides by 5. And now we have the quantity x plus 2 squared equals 9 times 5, which is 45. Square root both sides, plus or minus. And x plus 2 is equal to plus or minus the square root of 45. But we have to break down that into simplest radical form. Well, there was your simplest simplification right there. We'll break it back down into 9 times 5. Which is, we have x plus 2 is equal to plus or minus the square root of 9 times the square root of 5. At this point, you can take the square root of 9. And so x plus 2 is equal to plus or minus 3 radical 5. Last step, let's go ahead and subtract the 2 both sides. And we get x is equal to negative 2, right here, plus or minus 3 radical 5. Those are our two solutions, or our two zeros, or our two values of x. Number 13, we want to solve this quadratic using the method of completing the square. Let's do this. X squared minus x minus 8x plus, leave some space, plus 5 equals 0. Underneath that space, we are putting b over 2 squared, so b is negative 4. B is negative 8, excuse me, but negative 8, half of negative 8 is negative 4. Square that, we get 16. So we're adding 16, but we're also simultaneously subtracting 16, so that we're really adding 0, right? Section that off. That becomes my perfect square binomial of x minus square root of 16 is 4 squared. Subtract that. Minus 11 equals 0. Go ahead and add that 11 to the other side so we can begin solving this equation. And the quantity x minus 4 squared equals 11. We will square root that both sides like this. And x minus 4 is equal to plus or minus the square root of 11. Finish this off by adding 4 to both sides. And x is equal to 4 plus or minus the square root of 11. Number 14, algebraically determine the solutions to the equations shown below. Round your answers to the nearest hundredth, meaning we're going to put this in the calculator. Well, since the leading coefficient is not 1, I'm going to go ahead and use quadratic formula as a surefire way of solving this and getting the zeros. So quadratic formula, again, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. My a is 3, my b is 10, my c is negative 5. Plug this in. Negative b would be negative 10 plus or minus the square root of, it's going to be 10 squared minus 4ac would be 4 times 3 times negative 5, all over 2 times a, which would be 2 times 3. Let's clean this up a bit. Negative 10 plus or minus the square root of what? Well, 10 squared is 100. Minus a minus leaves a positive. And we got 6 times 5 there. That would be, or excuse me, it's not 6 times 5. 4 times 3 is 12, times 5 is 60. So 100 plus 60 over 2 times 3 is 6. So we have negative 10 plus or minus the square root of 160 over 6. Well, the square root of 160 is about 12.649, about there. Okay, your two solutions would be negative 10 plus 12.649 over 6, or x equals negative 10 plus or minus 12.649 over 6. In the first solution, we get approximately 0.44 when we put that in our calculator. I would urge you, when you put this in your calculator, put that in and then hit enter, then divide by 6. Similarly, put this in your calculator, hit enter, then divide by 6. For the second solution, you get about negative 3.77. In number 15, we have a parabola that is y equals 1/2 x squared plus 2x minus 3, and it's graphed. Algebraically, find the value of the positive 0 of this function. Express it to the nearest tenth. Well, so we're going to set y equal to 0 to find the zeros. You set y equal to 0 and solve for x. So 1/2 x squared plus 2x minus 3 equals 0. Now, I look at this and I just don't want to deal with that fraction there. So a nice little trick here would be multiply times the reciprocal of that fraction, which is 2, but multiply everything by 2, and you will not have a fraction anymore. It's kind of a neat little trick. So 2 times 1/2 would, of course, be 1, so that's x squared, and then plus 2 times 2, or 4x, minus 2 times 3 is 6, equals 2 times 0, which is 0. So this is kind of a nice little trick when you're trying to get rid of a fraction. You don't want to deal with it. Now I'm going to complete the square on this thing, so let's section this off. X squared plus 4x plus, leave some space, minus 6 equals 0. B over 2 squared goes here. B is 4, half of that is 2, square that, we get 4. So we're adding 4, but we're also subtracting it again simultaneously. And so I get my perfect square binomial would be x plus square root of 4 is 2 squared. And then minus 4 minus 6 would be minus 10 equals 0. Okay, so I kind of want to do this by adding 10 both sides. And I get x plus 2 quantity squared equals 10. Let's go ahead and square root both sides. X plus 2 equals plus or minus the square root of 10. Square root of 10 can really not be broken down anymore, because the factors of 10 are simply 1, 2, and 5. 1 times 2 times 5. That's what gives you 10. And none of those are perfect squares, so you can't really simplify that. But what we can do, of course, is subtract this from both sides, and we want the positive root. So here's what we see. Negative 2 plus the square root of 10, or x equals negative 2 minus the square root of 10. Now, you all should be able to look at this and go, a negative times a negative is just going to be more negative. That's your negative root. That's your negative 0. I want the positive 0, so I really want this. So I'm going to put that in my calculator. And negative 2 plus the square root of 10 is approximately 1.2. And that makes sense, because if I look at my positive 0 is here. It's really close. That's 1. It's really close. It's just a little above 1. Turns out, 1.2. And lastly, number 16, Evan graphs a parabola y equals x squared plus 4x plus 7 and finds that he has no x-intercepts. Explain how you can verify Evan's result algebraically by solving for the zeros of the function. Well, here's the thing. Zeros are the function, so x equals, so x squared plus 4x plus 7 equals 0, where a is 1, b is 4, c is 7. Now, to see if you have any zeros, to see if the function has real solutions or real zeros, you're going to, you can plug it into quadratic formula if you want to, but the easier way to do it, the faster way to do it, is just simply evaluate the discriminant. Now, what is the discriminant again? Well, if you go and you look at quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this value right here, b squared minus 4ac. Since the discriminant is under the radical, that is what limits what it can become. So if b squared minus 4ac is positive, you can take the square root of a positive number. Therefore, you get two real answers, plus and a minus. But if your answer is negative, if your discriminant is evaluated as negative, you can't take the square root of a negative number. Therefore, you will have no real solutions or no x-intercepts, as we saw in the previous video. So let's evaluate that function. Let's evaluate b squared minus 4ac. So b would be 4. B squared minus 4, that's part of the equation. 4a is 1, c is 7. So we have 16 minus 28, which is negative 12. The 12 doesn't matter. What matters is the negative. Since the discriminant is negative, there are no real zeros. So you can evaluate it algebraically by simply looking at the b squared minus 4ac part of quadratic formula called the discriminant. If the discriminant is positive, you have two real zeros. If the discriminant is a negative number, you have no real zeros.